Welcome to a new lesson. In this lesson, we would learn the fundamental idea why Hadoop data types were needed and why we didn't use the already present Java data types in MapReduce framework. To understand this, let us understand what serialization is. When the two processes intercommunicate, for example, map communicates to reduce, then in that case the data is transferred in terms of objects. Serialization is the process of turning the structured object into a byte stream for transmission over a network or writing to a persistent storage which eventually would be read by another process. Deserialization, on the other hand, is the process which the receiving process does to the byte stream it reads. It is the process of turning the byte stream back into the series of structured objects. Interprocess communications happens by RPCs, remote procedure calls, in Hadoop. Features that are needed in serialization for it to be effective with remote procedure calls are: first, compact. The messages that are transmitted over the network bandwidth should be as small as possible. The smaller the data transfer, better would be the efficiency. Second, fast. Serialization and deserialization should happen quickly. This is in many ways related to the first point. If the serialized data is smaller, the process of serialization and deserialization would be fast as well. Third, extensible. Protocols change over time and it should be able to meet the newer requirements. And lastly, interoperable. It is desired that the process written in one language can communicate with the process written in another language. For example, map might be written in Java and reduce would be in some other language, say Python. Then in that scenario as well, the serialized framework should be effective. So now we understand that Hadoop works on remote procedure calls and serialization is an important underlying concept for its efficiency. But why Hadoop needed new data types? Could it not use the Java serialization framework itself? The answer to the question is that Java's inbuilt serialization had a few shortcomings. First and most importantly, it wasn't compact. It had overheads when the data was serialized. Java serialization would send the metadata like the class definition along with the data sent. This considerably increased the serialization size and as well increased the processing time. It was basically designed as a general purpose inter-process communication mechanism. The Hadoop serialization framework assumes that the client already knows about the data that is to be expected from the sender. This decreases a lot of overhead, and this writable serialization framework was designed. Let us take a look at the framework. Here, writable is an interface. Writable comparable is an interface which implements writable. And then we have data types which we use as keys and values in MapReduce framework. Next, we see the table which shows all the Hadoop data types and their corresponding Java data types so that we can draw parallel and understand and relate to them better. I've put them in notes for this lecture so you can have a look at them in details there. Even a custom writable implementation can be done by extending the writable comparable interface. But in that case, the following functions should be overloaded, majorly because they are inherited from the interface or are being used in sort or shuffle stages. I've put an example of custom writable along with this lesson. Please go through it and have a look at it after the lesson. But as you notice that the writable framework only supports Java data types and is language dependent. So Avro, a language-neutral serialization system, was conceptualized. It is a project by duck cutting so as to build serialization framework that supports many languages. Another advantage with Avro is that it future-proofs the data, allowing it to outlive the language used to read and write it. Again, the important principle is the same. Avro assumes that the schema is present both at the time of read and write. Avro schemas are written in JSON. This is an example of how a schema is declared in Avro. This contains the field and the name and the type of fields. The schema needs to be declared in the reading and the writing programs. Avro is an advanced topic, so we would stop here itself. I would recommend the exercise given after the lesson to build more knowledge in this field.